Welcome to Academic Gladys class. So in today's class, we're going to be treating circuits in parallel and series. How to solve problems on circuits and series in parallel. So first, how to identify circuits in series. So if I have a capacitance, let's say if it's a capacitance we're looking for, or capacitor. If this is a line, and I have something of this nature. Are you seeing it? So it's more like it's this way now. Or let's say it's in this order. And I have another one this way. These are in series. So if something goes this way, maybe. So when I have it in this direction, this way and this way, you can say it's in series. So 1, 2, that is this one, and 3. So these are the formats to take note of for it to be in series. And we know that to find capacitors in series is simply given by 1 over C total equals to 1 over C1 plus 1 over C2 plus dot 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 1 over Cn. It's up to any number. So while if it's talking about parallel, you need to remember that parallel lines, when you hear something is a parallel line, it means two lines that can never meet. So it's either this way or in this order. So that means for this one, like this is the first format, this way. So that means when I have something like this, now let's say I have a circuit this way, and I have another circuit this way, this order. I see it. So let's say I have the voltage somewhere here. Let's say I have something like this for the voltage. It can be somewhere down too, it doesn't matter. But once I see it on two different lines, so this is the second format you can have it. So let's say I have something of this nature, and then I have it connected to something of this nature. So let's say maybe I have the voltage this way. So you can see that provided that you see this in such a way that it is on two parallel lines or this way, so you need to know that. So with that said, there's a question up here. It's tutorial question. They say give names of the circuits above, then give the charge capacitance. So for A, so we can say to answer this now question, so solutions to tutorial question. So A, that is Fig A, is equals to capacitors in series, while Fig B is equals to capacitors in parallel, or capacitance in parallel. So you can see the circuits. So this is a straight line. Assuming it's even somewhere here, it's still series. But notice that once you have parallel lines, this is a parallel, this line is parallel to this. So in parallel. So to calculate this, to find, let's say, give the charge, capacitance and voltage of the circuits in Fig A and Fig B. So for Fig A, using this drawing, to find the capacitance B, to find the capacitance will simply be 1 over Ct is equals to, how many charges do I have here? 3 capacitance, sorry. I have 3 capacitance there. So I'll have 1 over C1 plus 1 over C2 plus 1 over C3. And this is the same thing as saying 1 over C total capacitance is equals to, the first thing there is 636. So 1 over 6 plus 1 over 3 plus 1 over 6. So if you take LCM here, you see that this is 1 over Ct is equals to, LCM here should be 6. 6 into 6, 1 plus 2 plus 1. So this should be the same thing as saying 1 over Ct is equals to 4 over 6, 2 here, 2 here, 3. So you see that 1 over C2 is equal to, so this is the same thing as saying cross multiply. So this becomes 2CT. That is capacitance total. The T there stands for total capacitance is equals to, this one go over here 3. So that means that the final answer making CT subject of formula is divide both sides by 2. This will cancel, so that the total capacitance will be equals to 3 over 2, which is 1.5 microfarad. So I'm using microfarad. So and you need to note, so that you don't forget, we are going to solve this. Okay, you need to note. I'm coming. In as much as I'm not using it, so just let me write notes. It's not part of the question, but let's just note it. 1 microfarad, sorry, 1 million, sorry, 1 farad, sorry, 1 farad is equals to, I know some people will like to do 1 microfarad is equals to 10 raised to the power minus 6, but I don't like doing it that way. So 1 farad is equals to 1 million microfarad, while 1 millifarad is equals to 1000, sorry, 1 farad is equals to 1000 millifarad, and 1 farad is also equals to 1 billion nanofarad, and 1 farad is also equals to 1 trillion, should be 6 zeros, that is 12 zeros, picofarad. Please note it. So is the same thing as saying one of these, now 1 picofarad will now be equals to 1 times 10 raised to the power minus 12 farad. We'll still do that one if we want to convert, but no need. So just note. So back to business. Back to our business. So still on this first circuit, to find the charge here, you remember that the charge on series, on a capacitor in series is the same, but the volt is different. That is, the electric potential is different. So to find the charge will simply be Q is equals to CV. That is, Q will be equals to the capacitance. We got it to be 3.3 over 2, which is 1.5. So the voltage given to us in the question is 16. So times 16. This is the one I'm solving for. So that you now have 1.5 times 16. So you get 24. Q is equal to, remember we used micro farad for the capacitance, then we'll times by voltage, that is, so this is going to be micro coulombs. This is micro coulombs. So you need to know that if you want to convert it to coulombs, you times it by 10 raised to the power minus 6. So then for the, this will be the charge. Then for the voltage, V will be equals to Q over C. So I need you to note something. The charge is, when you apply this voltage, if you enter here, the first one will have more voltage. Work is done here. As you move here, it will reduce, it will drop. You see it? It's unlike parallel that when you apply this now, it will come here. As it's moving straight, it will go to this one, go to this one. Voltage is the same for parallel, different for this for series. So to get the voltage now here, all I need to do is to simply compare each of these. So compare each of these, that is, use the charge that is the same and divide by 6, by 3, by this. So it will simply be the same thing as saying voltage in capacitance 1 will be the same thing as saying charge divided by capacitance 1. And voltage in capacitance 2 will be the same thing as saying charge divided by capacitance 2. And voltage in capacitance 3, or capacitor 3, sorry, will be equals to charge all over C3, capacitance 3. Or you say capacitor 3. Capacitor is the device, capacitance is the attribute or the thing it is. So V1 will be equals to 24 divided by 6. V2 will be equals to 24 divided by 3. And V3 will be equals to 24 divided by 6. So reason being that capacitance 1 is 6 microfarad, 2 is 3 microfarad, and the last one is 6 microfarad. It's always important to convert your answer from microfarad to farad. I'm using microfarad, but I would advise you always convert to farad and coulombs, because that's the units, the actual units. So this will be the same thing as saying 24 divided by 6 should be like 3, right? Sorry, 4. What are you saying? So V1 is equals to 4 volts. So V2, so 24 divided by 3, is this 8? Okay, equals to 8. Then that means that 8 volts. So while V3 is equals to 4 volts. So let's do something. 8 plus 4 plus 4. So you will see that by the time you do V1 plus V2 plus V3, it should give you V total voltage. And that means that if you do 4 plus 8 plus 4, it should give you 16 volts. And remember, if you look at this very well, that's how to know if you are correct. If you look at this very well, what you have here is 16 volts. So you are correct. Now to solve for, and okay, then to solve for, now for fig B. So remember, it's fig A we solved for. So we started with fig A. So this one is for fig A. The one in series. So now for fig B, we'll come here. We have 25. And so if this is moving here, that means this is capacitance 1 and this is capacitance 2. You need to note that. And in capacitance 1, you have the first charge, you have the second charge. Microfarad there is for capacitance. So if that is the case, let me remember. Go and check our video on how to derive capacitance for parallel and series. So capacitance for parallel capacitor is given by C1 equals to C total plus C1 plus C2. Since it's two things they give us, so C total will simply be equals to, they give us 25 and 13. Then voltage, so 13 plus 25. 13 plus 25 is equals to, so you just, please don't confuse this thing. You can leave this thing without putting this C. This C just means total capacitance. So it's equals to 38. I'm going to use microfarad. So if you now want to convert it to farad, you can say times 10 to the power minus 6. I don't like doing that shit, but it's the best thing to do, because most of the time in the option you will not see this microfarad as the answer, you see it in farad. So now, since we've gotten the capacitance, to get the charge, you need to know that voltage will be the same. So that 12 volts given to us, this 12 volts given to us here, is the same. So voltage is the same, that is same, equals to 12. That is parallel capacitance or capacitor have the same voltage, but the charge will be different. So which means that as I have C1, C2, I should have Q1 plus Q2 equals to total Q. And to get total Q is to remember, first of all, remember Q equals to CV. So that means that I will come and do for the first, so for Q1, So for Q1, it will simply be C1 times V. Remember V is the same, which is Q1 equals to C1 is 13 times 12. So 13 times 12 is 156. So Q1 will be equals to 156 microcoulomb, because this 13 is a microfarad. So, and for Q2 it will be C2V. So that is Q2 will be equals to 25 times 12. So 25 times 12 is equals to Q2 will be equals to 300. Now, that means that the total charge, therefore 156 plus 300 should be equals to total charge, and that is total charge will now be equals to 456 microcoulomb. This is microcoulomb. To confirm this answer, if this answer is correct, we need to go back to our total capacitance. Use our total capacitance and times our voltage. Let's see. So remember, to confirm the answer, remember Q equals to CV. Therefore, Q equals to CTV. Q equals to CTV. Then CT, that is our total capacitance, is 38. This one, yeah. So times 12. So 38 times 12. If you do 38 times 12, Q equals to 456. So we are correct. So there you have it. That's how to go about it. So in our next class, we'll be solving this question. So you can take your time and solve it. In our next class, we'll look at these questions. So this is a situation whereby you now combine parallel resistors. It's in parallel resistors, and this is the voltage. Now, okay, in this case, this second question is a perfect example. The case where you have, if you look at this, these two are in series because they are on the same line. And if you look at it, they are this way in series too. But notice, these two are parallel to each other, and this is parallel to this. So when you have combined, that's why I told you we have capacitors in series, capacitors in parallel, and capacitors in series and parallel. So in our next class, we'll try to look at these questions, but you can take your time and see if you can solve it. Thank you. Bless. Subscribe to my channel. Good number of you will come to my DM and say, I like the way you teach. You need to be subscribing to my channel to make my channel grow, make other people be able to view my channel, help this channel. Remember, this is Q2. Okay, Q1, and this is Q2. Here is the sign. I drew this thing very small. I just hope you can see it.